tried to do that. So, all right. So what you could do now is, if you have your assignments with you, you could be going over them as I go over them here. Or if you don't have your assignment with you for some reason, like if you're at your other parent's house and you left them at the other one, then you could just follow along, or you could try them on your own piece of paper, but I'm not going to write the whole problem down. Hopefully you have the textbook with you. So this is page 54, and I'm looking at number 13. So the key there is that, and this is how I know some of you weren't checking your work, is because in the back of the book it explained it a little bit better. But if you're going to say a limit does not exist, especially if it's because the left and the right side don't approach the same number, on the AP test, on a free response question, you need to show that. So what we needed to see here, only a couple of you did this. Now it would have been nice if this function had a name like f of x, because then I could have just written f of x here, but it didn't. So if we approach 5 from the left, we would be plugging 4.9 in there. And we would get the same decimal, but the numerator would be positive and the denominator would be negative, so that's going to be -1. Okay, and we actually should write that down in our work. So I'm not trying to waste your time. I'm trying to have you write that because that's what you have to do on the AP test. So when I did the notes, I'm pretty sure I mentioned this because there was a couple examples where I wrote it out like this. So I think when we were trying to establish continuity to show the left and the right side. Now if we come in from the right, that means that we're going to be 5 point something. So again, we're going to get the same values here, but this time they're both going to be positive. So that's going to be +1. And then we would say that -1 does not equal +1, so this limit does not exist. All right? So most of you had does not exist, but your explanation wasn't thorough enough, and it suggests that maybe you didn't check the back to check that. And sometimes you don't check stuff because you think it's so easy, but it's still worth checking. All right, number 14, same page, we had a problem there. Some of you said that the limit was approaching infinity. Now sometimes we do say that limits are approaching infinity, even though it means it does not exist, because infinity gives us more information. If we come in from the left, we head towards 3 from the left, that would be 2.9. That's going to make this 1 divided by a really small negative number. And when we divide that, we get -infinity. Now, if we come in from the right side, 3.1, this is going to be a positive number, but it's going to be very small. So I take 1 divided by this tiny, tiny, tiny number, I get +infinity. And here, because those are different, we're going to say -infinity does not equal +infinity, does not exist. Now, if they were both +infinity, then we could put +infinity as our answer. Now, if it's a free response question, either answer will be correct. So if this is a free response question, you put does not exist, you'll get it right. If you put positive, well, not this one, if they were both positive. If you put +infinity, if they were both +infinity, you would get it right. If it's a multiple choice, they won't have both choices because both of them are right. So they won't do both. Any questions on that? And then number 17, what I would have liked to have seen was that you had it oscillating. So maybe, I don't know what the graph looked like exactly, but something like that. And it just keeps going back and forth. And if you try to zoom in, it just keeps going back and forth. So the reason it does not exist is because it oscillates. Okay? So just a little bit more details on those. Now, the next one I want to do is number 23. So, number 23 was a delta epsilon proof, and they're never going to ask that on the AP test, but I usually ask it on a bunch of my tests, but I still haven't decided how I'm going to do my tests. So, at this point I would say you should know how to do a delta epsilon proof. All of you should get this right. all you have to do is memorize the steps. The steps are the same almost every time. There's one tiny difference. So, as I told you to adjust your notes, the first step should always be like that. And then all you do is you put in C right there, minus C. So, this one was approaching 2. So there's step 1. Step 2 was calculate the limit. So the function was 3x plus 2, and x is approaching 2. So when you plug in 2, 3 times 2 is 6, plus 2 is 8. So the limit is 8. So that was step 2. Step 3 is the function, which I just said was 3x plus 2. So you could have your book open right now, and you could be following along in your book, if that's helpful to you, or you could have your assignment out, or both. And then it's the function minus the limit, which we just found right there. So we're always going to plug this in right here. And then that is less. And now here's where we have two different kinds of problems. Sometimes we put epsilon there, and sometimes they give us a number. This time they gave us a number, so we're going to put that number there. If they don't give us a number, then we're going to put epsilon, just a curvy E. Okay, so that was step 3. Step 4 is to kind of simplify this stuff and factor out a 3. So the whole point there is to get this to match that. And then the last step is to divide both sides by 3. Now, if you paid attention to the notes that I did on YouTube, you would notice that I did not leave it like that. We don't normally leave decimals inside of fractions. That's awkward. So in our notes, I actually divided that out. And the 0, 0. So we need to add a 0 on here. So that's going to be 3, 9, 1, add a 0. We kind of need to look at that, but that's it. So the answer is 0.003. And in the notes that I videoed for you, I told you that the AP exam goes to the thousandths place. If you don't have that decimal right, you get it wrong. So we really need to make sure that we're getting that decimal right. So on the calculators that I checked out to you, you want to make sure you're in fixed 3 mode. So if you go to mode and you go down, there's like float or fixed. I guess we could look at that real quick. So if you hit the mode button underneath the alpha button, and then the third one down, it says display digits. And oops, that's not what I wanted. I need to hit the arrow. And then you have some choices. It says the choices are fixed or floating. And I want mine fixed 3. If I have it on fixed 3, and then you want to hit enter, and then enter again. That means it'll always give you 3 decimal places. Let's try it out. 1 divided by 3. Oops. Oh, that's y equals anyway. Let's go to the home screen. 1 divided by 3. So you see it just gave me 0.333. Now, usually I have that So what I'm doing now is if you scroll down in the mode menu, it says exact or approximate. So I usually choose that to be an automatic, which means that it will give you your answer. So I gave it 1/3, so it's giving me my answer as 1/3. So if your answer is in fractions, it's going to give it to you as fractions. If it's in decimals, it's going to give it to you as a decimal. Now there's 2 ways you can make it give you a decimal without changing your mode. One is use the green button up here and the enter, which is approximately. That will give you a decimal. Or if you put a decimal, so 1 divided by 3 point, you don't even have to put 0.0. That will give you, if it's got a decimal in it, it'll do a decimal as well. So those are 2 ways. We'll talk about that more later, but all right. So now I'm going to go to page 65 and look at number 48. So that was asking for the limit as x approaches -1, and it was x cubed plus 1 over x plus 1. So x cubed plus 1 is the sum of two cubes. X cubed plus 1. So I went over that in your notes 3 times. You take the cube root, same sign, cube root. And then you square the first thing, and then you take the opposite sign. Then you multiply these together. So this is where some of you got this wrong. That should just be minus x, not minus 2x. So some of you put minus 2x. And then you square the last thing, so that's going to be positive 1. Okay? So these are going to cancel. That means that's a removable discontinuity, which we don't need for this problem, but that's what it means. Now we can use direct substitution because we just have a polynomial, and that's fine. And then we had some people mess up the math over here. So that's a -1 squared minus a -1 plus 1. So that's 1 plus 1 plus 1 should be 3, not 1. 1 was the most common mistake, I think. Any questions on that? Okay, moving on to page 76. Now, this is an easy question if you know what you're doing, which I guess we could say that about all questions, huh? So, it asked for the limit from the right. So it was a piecewise function. That means that you have to look at which piece is to the right of 1. And that was the bottom piece. Usually the lower piece is on top. So that was 1 minus x. Some of you used the top piece, which was when x was less than 1. This is not x less than 1. This is x more than 1. Now you just plug it in there. So that would be 1 minus 1, which is 0. Okay? Some of you are leaving off the functions and you're just writing the limit like that. That's not good. Notice how I'm not putting equal signs in between things, because if you are doing steps and sometimes you leave this off and you just do the algebra part and you put an equal sign, this is not equal to this. So the safest thing to do is not put too many equal signs in between things. That's why I didn't put equal signs down here. Any questions on that? So now I'm going to do number 42. Number 42 asked you for the discontinuities. Discontinuities. And it was just a function. And it was x minus 1 in the numerator. And the denominator was x squared plus x minus 2. So usually when we have rational expressions, we're factoring stuff. So it had to be like that. The 1 in the middle was positive, so it factored like that. Now it's asking you where that's discontinuous. Well, there are 2 types of discontinuities, okay? And I'm pretty sure I went over that in the notes. And I usually ask this on like 6 tests in a row. And there are 2 main types of discontinuities in a problem like this. One is removable, and the other one is vertical asymptote. So this actually has 2 discontinuities. It's discontinuous at -2 and at 1. So that's the first part of the question. Where is this discontinuous? It's discontinuous at both of those. And then it also asked us, is there a removable one? So we could say 1 is removable. These cancel, that's why 1 is removable. Then it would just be 1 over this. But the asymptote, x equals -2, is also a discontinuity. So that's a common question I ask. I know I'm repeating myself, but I ask it a lot on tests. And you've got to be careful not to fall for that trick. Am I asking for removable? Am I asking for asymptotes, vertical asymptotes? Or am I asking for all discontinuities? Okay. Any questions on any of these? So number 23 was the same rational expression as we had number 48 up here. It was x cubed plus 1 over x plus 1. Well, I can see what I get this. And the question said, are there any vertical asymptotes? Oh, we'd have to have a restriction on this. X cannot be -1. Does this have any vertical asymptotes? No. No vertical asymptotes. It does have a removable discontinuity, but that's not a big deal. All right. Last one. The limit as x approaches 0 from the right of 2 over the sine of x. Now, it might be helpful here if you know the graph of sine. So the graph of sine kind of looks like that. I guess I could have used the blue lines there and made it a little bit nicer, but so x is approaching 0 from the right. So that's right here. So that means we're going to have 2 divided by 0.000. Okay? So that's a really tiny number. How many times does that go into 2? Infinite. Now, if we're approaching 0 from the left, then this would be a negative, and then that would be negative infinity. Okay? Any questions on that?